During this presentation, we'll feature Thermo Scientific Avizo Software for composites, polymers, and fibrous materials. We'll explain how it helps more than 3,000 researchers, academians, and industry professionals around the world to better know their advanced materials thanks to dedicated features developed by our experts in close relationship with the scientific community. Your innovative materials play essential roles in safety, clean energy, transportation, human health, and industrial productivity. To fuel continued innovation, you want to deepen your understanding of the physical and chemical properties of your materials, whether morphological, structural, magnetic, thermal, and mechanical at any scale. Avizo Software provides optimized workflows for advanced material research and quality control from a single environment, allowing you to focus on your expertise. Avizo Software is a trusted solution that has been adopted by many researchers around the world. As you can see on this chart, every year, more and more publications use Avizo Software to visualize and analyze their image-based data. Avizo Software is a reliable, fully automatable, and customizable solution that uses cutting-edge technologies to offer the best visualization and processing tools from a single environment. From straightforward visualization and measurement to advanced image processing, quantification, analysis, and reporting, Avizo Software provides a comprehensive, multimodal digital lab for advanced 2D and 3D materials characterization and quality control. Avizo Software provides dedicated tools to allow you to better visualize, analyze, and obtain actionable results from your image-based data. Avizo Software has advanced fiber analysis capabilities. You can easily apply automatic segmentation of your individual high-resolution fibers to know the major orientations of your low-resolution fibers. You can apply quantification, such as contact point or distance to closest neighbor. You can also obtain fiber shape statistics, such as diameter, length, tortuosity, area, volume fraction, or cross-section perimeter. You will also be able to obtain fiber density-related statistics, including volume fraction area and tensor per material subdomain. Avizo Software allows you to also generate a 3D plot of fiber orientation on a sphere or half sphere with properties mapped as color and height, in addition to using advanced fiber filtering modules. You can also easily apply meshing on your fibers and export results to major solvers file formats. For porosity analysis, Avizo Software allows identification of pore throats and separation along them. It enables the conversion of the pore space into a model, known as a pore network model, representing pores and their connectivity. Various properties can then be color mapped onto this pore network model. Avizo Software also provides advanced pore space statistics such as pore size distribution, pore throat size distribution, channel length, and more, and it provides filtering of the model based on property. The entire field of imaging is becoming very popular for different applications, and we cannot capture the changes in morphology during time-dependent studies. Some deformation is taking place as a result of these changes, but to take it to the next level and quantify the link between the microstructure and mechanical behavior, you need a much more advanced technique such as digital volume correlation, also known as DVC. The visualization and quantification tools are often limited and not adapted to 4D imaging applications. And most of the time, the results are saved into images where you can have a size of a few gigabytes, and these can add up rapidly during this analysis. Avizo Software DVC extension has been specifically designed for 4D imaging applications. It's a unique solution combining different features. The upcoming slides will highlight some partners' use cases: 3D fiber reconstruction in fiber reinforced concrete or FRC, fiber characterization and orientation analysis in woven glass fiber composite, new generation design of glass furnace and pore coalescence related to fracture of a fiber-reinforced polymer composite. Fibers are used in concrete to increase its structural integrity. The characteristics of fiber-reinforced concrete change with varying fiber materials geometries, distributions, orientations, and densities. Avizo Software enables characterization of the tensile strength of the FRC by identifying the fibers and providing their average orientation. Further quantification is performed to analyze porosity distribution in the concrete based on pore network modeling technique. The University of Manchester selected Avizo Software as a solution to visualize and analyze all the image-based data they generate. This use case comes from a joint scientific article published in 2015 by the Henry Moseley X-ray Imaging Facility, the Aerospace Research Institute from University of Manchester, and Thermo Scientific. The title is Evolution of Damage During the Fatigue of 3D Woven Glass Fiber Reinforced Composite Subjected to Tension Loading observed by time-lapse X-ray tomography. 10 images were acquired during the fatigue test. Data modality was a Nikon Metrology 225-320 kV custom bay with an accelerating voltage of 70 kV. Thanks to Avizo software segmentation capabilities and the use of a contrast agent, the growth of damage with increasing numbers of fatigue cycles could be effectively detected. To easily classify the XY fibers and the resin, a texture-based segmentation had been applied using Avizo software. Here's a video using Henry Moseley X-ray Imaging Facility data illustrating this use case. This example is taken from the PhD work of Kamel Mahdi in collaboration with Saint-Gobain. Its aim was to improve the fabrication process of zirconia refractories used in glass furnaces. The ceramics have a manufacturing process different from the way traditional ceramics are fabricated, sintering. They are formed by solidification, similar to the way metals are formed during foundry, electrofusing, casting, coating, with a microstructure developing into a network of interlocked dendrites, 88% in volume, embedded into an amorphous phase, 12% in volume. During the coating stage, they undergo several changes such as creep at high temperature, zirconia phase transformation, and thermal expansion mismatch. The zirconia phase transformation stage needs to be better understood as it affects the performance of the final product. In service, the furnace is subjected to high temperature creep and corrosion by the corrosive glass. In situ experiments were performed at the Soleil synchrotron in the Psyche beamline using a bespoke furnace designed to operate up to 1400 degrees Celsius. High flux and fast imaging with continuous streaming were used to capture all the morphological changes occurring during the phase transformation of zirconia. Zirconia changed from tetragonal to monoclinic with a 4% volume increase between 1020 degrees Celsius and 850 degrees Celsius. A global FEDVC approach was used to compute the displacement and strains between 1020 and 850 degrees Celsius. Validation of the DVC results with another technique produces good agreement between the DVC and the datometry measurements of thermal expansion coefficients and detection of phase transformation onset. Although the transformation is followed by a 4% volumetric change in all directions, locally the strains are heterogeneous and complex. Bands of high volumetric strain developed in the material. These strains can be linked to the microstructure, notably the variability of the microstructure and the volume fraction of amorphous phase. Effort is ongoing to link this work with thermomechanical simulations at different scales. To conclude this presentation, we want to highlight the Xtra Library. It is a free online portal that provides a collection of add-on recipes, scripts, and demos dedicated to specific use cases and workflows. Recipes accessible via the Xtra Library can easily be uploaded to Avizo software with just a few clicks. This will allow you to shorten your time to results and focus on what matters the most for you to dramatically increase your efficiency. This is new. Avizo2D Software is a simplified but powerful version of Avizo software designed with maximum ease of use in mind. Performing automated, reliable image analysis workflows, it allows users who are not image processing experts to seamlessly classify features and extract accurate quantitative information from 2D imaging data. This presentation is now over, and we thank you for your attention. It's now time for you to request a free Avizo software trial. If you have any question, please contact us using the form below this video.